We used to think that moons were a luxury only reserved for big, important planets. But in 1993, the Galileo spacecraft was flying past a random asteroid named Ida when it spotted something impossible, a tiny, separate rock circling it. It was a moon for an asteroid.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
Today, we know that space is full of these double trouble duos. How does a rock only 35 miles wide manage to keep a satellite of its own? Since that first discovery, astronomers have found that asteroids are a lot more social than we thought. About 15% of near-Earth asteroids are actually binary systems, meaning they have at least one moon. Some, like asteroid Cleopatra, even have two. It's like a miniature solar system, just on a much smaller, rockier scale. But where do these mini-moons actually come from? One of the coolest ways these moons form is through something called the YORP effect. Basically, sunlight acts like a tiny engine. Over millions of years, the pressure of light can make an asteroid spin so fast that it literally starts to fall apart. This spin-up sheds debris into orbit, which eventually clumps together to form a moon. It's like a cosmic pottery wheel making its own accessories. We've even started pranking these moons for science. In 2022, NASA's DART mission intentionally crashed a spacecraft into Dimorphos, the moon of asteroid Didymos. By hitting the moon instead of the main asteroid, we could measure exactly how much its orbit changed. This proved that if a dangerous asteroid ever heads for Earth, we can use its own moon to help us figure out how to knock it off course. While binary systems are fascinating, the asteroid belt is dominated by true giants that dwarf everything else. Meet Ceres, the largest object in the asteroid belt. It's so big that it's actually classified as a dwarf planet, spanning nearly 600 miles across. When NASA's Dawn spacecraft arrived, it spotted these mysterious bright, glowing spots inside a crater. It turns out they are massive deposits of salt left behind by evaporated water. This suggests that Ceres might be an ocean world, hiding liquid water beneath its icy crust, making it a prime target for hunting for life. Then there's Vesta, the second most massive body in the belt. Unlike the round Ceres, Vesta is lumpy and scarred, a relic from the dawn of our solar system. It has a massive impact crater at its south pole, a wound so deep it exposes the asteroid's mantle. The collision that created it sent debris flying across the solar system. In fact, if you find a meteorite on Earth today, there's a good chance it actually came from Vesta. We are literally holding pieces of this world in our hands. Beyond the main belt, Jupiter herds two massive swarms of asteroids called the Trojans. They share Jupiter's orbit, trapped in gravitational stability points. These Trojans are time capsules, fossils from the very formation of our solar system that have remained untouched for billions of years. But why do we study these rocks? It's not just for science. It's for our future. Asteroids are rich in platinum, gold, and rare earth metals. More importantly, many contain water. In space, water isn't just for drinking. It can be split into hydrogen and oxygen to make rocket fuel. This means asteroids could become the gas stations of the future, allowing our ships to travel further into the cosmos than ever before. From tiny moons to dwarf planets, and from ancient history to future mining, the asteroid belt is the next frontier, waiting for us to explore.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.